Alright, so yesterday we went over points, line complaints. Basically, as you can see at the very top of the page, we're going to be going over distance and midpoint formulas. So, get going here. We'll look at distance and midpoint. Here's what you're going to be asked to do today. Find the distance between 2 points using the distance formula. Also find the midpoint between 2 points using that formula. The third one, if you can count, you can do this. The directions make it sound like this is a really complex setup. The book makes it even worse. But if you just stop and think about it logically, if you can count, you can do that third objective. I'll show you how to do that. And then the last thing we're going to do today is we're going to talk about how to derive the distance formula, which is kind of important because that is a test item. So let's first of all talk about the distance formula itself. So if you guys look over here at the board, what shape do I have here? What type of triangle? Right. Okay, a right triangle. Now, there's this little theorem that most of you guys can scream out the name as fast as you can, but nobody can actually tell me what it means. Oh, Brandon. Yeah, what does it mean?
The sides add up together to equal 180.
No, the sides of a triangle do not add up to 180.
The angles of a triangle.
The angles of a triangle add up to 180 has nothing to do with the Pythagorean theorem. Tori?
It helps find the missing side.
How?
You take the two sides that you know and you add them together and square them.
Okay.
And then you can subtract it from.
Well, we're a little close on that. So let's start with you. This is, you know, the formula. Shannon, what's the formula? All right, so let's write that down real quick. So Pythagorean theorem says that a squared plus b squared is equal to c squared. Now here's my question for you. If I have a right triangle, guys, this only works in a right triangle. You can't use it in any other triangle. And this only works for a right triangle. So what is the A, what is the B, and what is the C in terms of the right triangle? Spencer?
The A and the B are the dotted line, and the C is the solid line.
All right, so C is my hypotenuse. A and B, it doesn't matter which leg they are, but they are the legs of that right triangle. You guys, the distance formula is this ugly, nasty formula. It's really not that bad. Really, it looks really nasty. In fact, I'm going to show you what it looks like, and we're going to give you a shortcut on how to handle that. It's really not that bad. In fact, what it really is the Pythagorean theorem. And that's it. Because here's my question for you. Let's suppose I just want to solve for C, right? Because that's what I'm trying to find. The distance from A to B is the shortest distance, which is a straight line connecting A to B. And therefore, that's my C of the hypotenuse. So if I look at this equation, how do I get C by itself? What do I have to do? No.
Oh, well, it's C.
How do you get rid of the square? Take the square root. So C is the square root of A squared plus B squared. So all you really think about, guys, this is really close to the distance formula. Very close. We'll talk about that later on today. So now here's my next question for you. If A and B are my legs, how would I find that length? All right, so here's my question for you. Let's do it this way. Let's say I'm on the number line. I'm currently standing at 4. And I walk a few paces, and then I finally stop at 15. How far did I travel? 11. Okay, simple, right? Common sense. I traveled 11. Brandon, how did you get that number? So you took your final and subtracted your beginning, right? Final minus start tells you the difference. Guys, that's like kindergarten. Okay, that might be a stretch. But, you know, that's like really low-level math, right? You just subtract them. Well, when we think about this, where A is at That's x1. The end of this dashed line is x2. So how far have I traveled? How do you figure out that distance? If I travel straight across, and this is x2, and this is x1. Subtract them, right? So that distance, that horizontal change, is nothing more than x2 minus x1. So then what about the vertical? So that's y2. Starting here, and going up to here. That would be y2 minus y1. And if these are the legs of my triangle, then I get the distance formula. D equals the square root of well, D is used for distance. x2 minus x1 squared plus y2 minus y1 squared. Oops, I do that in red. And that's the distance formula. It really is nothing more than the Pythagorean theorem. All you gotta do is subtract your x's, square, subtract your y's, and square them, and we're done. Let's do a couple examples. So there we go. One more time. So you got a chance to write that down. Distance formula is, there we go. D equals the square root of x2 minus x1 squared. Plus y2 minus y1 squared. Yay, distance formula. Yeah. So that's about it. Yeah, and Ray brought up a good point. Guys, in math is, okay, here's the way I usually describe it. Mathematicians are inherently lazy. Truly, they are lazy. They don't like writing any more than they have to. They don't like saying any more than what they have to. And so every single minute detail matters. The very placement of that 2 changes the meaning. The fact that that is 2 and it's underneath the variable means that it's basically representing a value. That's x sub 2. Okay, it's the second x value. The subscript 1 is the first x value. Now, when we put the number up in the top, now it becomes a power. Okay? That means the square or the cube. Okay, so that it's a big difference there with where you put these subscripts and superscripts. So please be very careful of that. Make sure that you're paying very close attention to your work. Okay, so here we go.